After disposing of the sewage in river, the DO, the dissolved oxygen, should not go down below a certain or prescribed limit, you can say. So that is why I will first teach you about what will happen if we will discharge the sewage in water body, and how can we calculate the dissolved oxygen of the mixture, effluent, like treated effluent and river water, and so on. So here you can see what I have already explained. There are two type of sewage disposal. One is in water body, that is known as the dilution method. Another is effluent irrigation or sewage farming, means disposal of sewage in agricultural field, agricultural farm. So in like the second case, basically when if we are disposing of the sewage in agricultural farm, then we have to also take care of pathogenic bacteria in sewage, because in agricultural field the sewage will come in contact with human working in the field, as well as the whatever crop is being is um, like sown over there. So that is why the high level treatment will be required in that case. However, in case of disposal in water body, the DO level or BOD should be reduced to a permissible limit. That is, most of the time that is enough, because there is a self purification mechanism happen in river body, uh, and that actually cleans the most of the remaining impurity with the course of time. Here, so dilution in river or self purification capacity of the river. So that is what we need to know before disposing of the sewage in river. Thus, so here what different process that may happen in the river are dilution and dispersion, which is a physical process, then sedimentation, the suspended or some of the suspended solid which remain in the sewage will get sediment. uh, there would be some purification because of the sunlight. um, then there would be some chemical you say reactions, oxidation, reduction will happen in the river. So here the dilution and dispersion in this, the addition of treated sewage into river having flow much larger than the effluent cause dispersion and dilution of organic impurities throughout the flow of the stream, thus reducing the potential nuisance of the sewage. So that is the mechanism which happens, or you can say the process which takes place in the river. So in that case, the concentration of pollutant C in the river in the mix, means after disposing of the effluent, can be determined by this formula CS into QS. This is CS is the flow of the sewage. No, concentration of the pollutant in sewage. QS is the flow of the sewage. CR is the concentration of that pollutant, for example say BOD in river. Then QR is the flow of the river divided by QS. So it's a kind of weighted average concentration we can determine. So this is simple example of the same. You can see that example. Now, what is the role of DO in natural river system? So see, the dissolved oxygen, as we know, uh, is used by the aerobic bacteria to degrade the organic matter and convert them to harmless compound, right? So that is what the main objective of DO in the river body. Uh, and a certain level of the dissolved oxygen should be maintained for the survival of aquatic life. So here I'm not going through each point, you can just read it. The same thing is written. Let me just read the final point. The dissolved oxygen that is used from the stream must be replaced by an anaerobic condition or anaerobic condition. So this is what, like, if the dissolved oxygen in the river body is not gained to a certain level which is required for survival of aquatic life, then anaerobic condition will develop, and that would be problematic. Two mechanisms are known to contribute oxygen to the surface water. So at when we dispose of the sewage in the river, there is a possibility that the sewage has some BOD left, right? Say 30 mg per liter, and that BOD, which indicates the presence of organic matter, will be further degraded or using, like, through by the bacteria using the dissolved oxygen. So there is a uh, like, in this way the dissolved oxygen of the mix will decrease, right? But at the same time the process, right, like, aeration is happening. The natural aeration is happening in the river body, and that aeration depends upon the dissolution rate of oxygen in the water, and also the temperature of the water body. And this can also be done by algal photosynthesis. So algae also produce the oxygen. So two processes are happening in the water body when we dispose of the sewage in the water body. One is deoxygenation process, which is decrease of oxygen. The other is reoxygenation process, which is replacement of or re-aeration of the water body or production of oxygen by photosynthesis. So basically, what will happen then? Uh, there would be some maximum or saturated oxygen level of that river body, right? So that oxygen level, saturated oxygen level, will go down, right? So at a certain time, the actual dissolved oxygen can be determined. So the difference between actual dissolved oxygen and saturated DO, right? So, that is known as oxygen deficit of the river at a particular time. Okay, so this is how the oxygen deficit is one of the parameter, you can say, or one of the quantity you need to know uh, to determine that if it is safe for it is safe for us to dispose the sewage into the river or not. Okay, so this is oxygen deficit. And now what I have told you just before, like deoxygenation and reoxygenation, here you can see on the right hand side the curve where the dissolved oxygen is on y-axis and time in days on the x-axis. And you can see that with, like, after disposal of sewage, the red curve, which is like cumulative depletion slope, means this is the deoxygenation. It represents the deoxygenation rate of the river. And the S type curve, which is green one, represents the reoxygenation rate of the river. So the net curve, which is like blue line, is known as the SAG curve, okay, or oxygen deficit curve. So you can see after a certain time, right, when the deficit is maximum, okay, there is no further, means probably all the organic matter is degraded by the bacteria, maximum oxygen is consumed. After that, probably the reoxygenation rate is higher than deoxygenation rate, therefore the deficit will decrease. And this point when deficit is maximum is known as critical point. Okay, and the TC means the day or the time corresponding to this critical dissolved oxygen concentration or oxygen deficit is known as TC, critical time, and this is the like these two parameters should be known first, like either theoretically you should if you know the the characteristics or chemical characteristics of the river water, then this can be determined. If even if like during the disposal also this values should be monitored in the river, so that it should not exceed you can say the maximum limit, permissible limit. Okay, so this is the critical point I have already explained you. So there are some formula where we can determine the oxygen deficit rate with respect to time. There is no derivation given. The basic assumption or basic you can say fundamental of this equation is that the deficit rate is linear, means it's a proportional to the dissolved oxygen or the BOD, ultimate BOD, and oxygen deficit itself. So it's a you can say linear first order equation. Yeah, that is the correct term we can use. So like the first equation, which is dd upon dt is equal to kd into lt minus kr into d, where d is the oxygen deficit, kd is deoxygenation constant, kr is re-aeration constant or reoxygenation constant, lt the oxygen equivalent of organic matter at any time t. So if you integrate this equation, then dt can be given by the formula given here. Just I'm going through the different terms so it will be clear to you. dt again uh, is the do deficit in mg per liter after t days. L is the ultimate first BOD. We have learnt about that ultimate first BOD of the mix, not of the sewage or effluent. It's of the mix at point of waste discharge. D0 is the initial oxygen deficit of the mix at the mixing point in mg per liter. Kd is deoxygenation coefficient for the wastewater. Okay, and it depends upon T, means temperature, and this is the formula regarding the KDT and linked with the KD at 20 degrees centigrade. The typical value of KD20 vary between zero point 0.1 to zero point 0.2, generally taken as 0.1. Kr reoxygenation coefficient, and Kr at 20 is given by this. So the Kr at T is also given here, which can be used in case the temperature is different than 20 degrees centigrade. So we, as I told you earlier also, other than what the DO or the oxygen deficit and at any time T, we should also know the critical time and critical DO, right, of the river. And these are the formula you can use for determination of TC, critical time, and DC, which is critical DO. And when you replace, so this part which I have written in red is given in the book. This is in page number 201 of the book. When you replace the kd upon kr by f is known as self purification constant, and this self purification constant for different water body is also given on page number 200 in the Gerk's book. Okay, in case it like in your exam, either it will be given or you can also find out in from the internet. So this is very common. F values are very common, and you can have it from the internet also. So kd upon kr is equal to f. If we will change this in this two formula, we can derive a formula for dc in terms of f, l, and du. Okay, so that you can try in home. So these are some of the examples. Please go through the example to, okay. See, there are many examples given in this book. I think they are very simple examples. Let me see how many examples are there. Uh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, 10 examples are given. Okay, let me, what I can do, I can take the photos of this and maybe I will upload this much, at least I will. Okay, let me see. I will try to just upload the photo of this example, so it will be it's easy for you to, if you don't have the books. Okay, so these are the example. You can go through it. Homework is given here. You can try this particular homework. Now, after this, the next topic we would like to learn is water treatment process. Where is my second slide? No, to disconnect it. Yes. 1 minute, okay? Where is my second slide? It's not showing up because yes. Yeah. So yes. So like after knowing the characteristics of river body in which we would like to dispose of the effluent, wastewater effluent, we need to decide on what kind of processes and what level of purification is required. So in general, like the common practice is to use the preliminary, primary and secondary process. Tertiary treatment is generally not used until it is very much required. As I told you, like in case if we are like disposing of the sewage in agricultural field, then the tertiary treatment may be required. For example, that the killing of pathogenic bacteria and all would be required. 1 minute, somebody is at 1 minute. Yes. Okay, so preliminary, primary, secondary, and tertiary treatment. These are the like four, you can say, type of treatment, or they are the sequence of the treatment. Uh, so as I said, the tertiary treatment is done only if it is required. For example, if I want to dispose of the sewage in agricultural field, we need to remove the pathogenic bacteria. In that case, that treatment is known as the tertiary treatment. So what I want to say is, in general, the pathogenic bacteria removal from the sewage is not practiced until it is required. So this is just an example. There are other tertiary treatments also. So now the unit operation, there are two. You can further categorize the treatment processes in two type. unit operation and unit processes. Operations means all the physical mode of treatment is known as unit operation, while if chemical or biological activities are involved, then the process is the treatment is known is like you can club under unit processes. Okay, so unit operation, it involves the contaminant removal by physical forces, right, like sedimentation, grease chamber and all. Unit processes, it involves biological or chemical reaction type of treatment in which the removal of contaminants is made by addition of chemical or by use of biological mass or microbial activities. For example, suspended growth process, attached growth process, etc. Now, if there is another way to like you can say categorize this treatment, as I told you earlier also: preliminary treatment, primary treatment, secondary treatment and tertiary treatment. So preliminary treatment is basically all the physical process in which the large you can say the large contaminants like stone, um, uh, uh, wood logs, right, and other big you can say big contaminants are removed by various processes. Along with that, in preliminary treatment, oil and grease is also removed. So overall, this treatment reduce the BOD load by 15 to 30%. And the different you can say devices used in preliminary treatment are screen to remove the wood logs, stones, and big any big object. Then there is a commuter. Commuter are the devices which can grind the remaining like big objects which have passed the like first screen, and then grinded this the water containing grinded contaminants will be passed through the fine screen to remove those contaminant. And then after that, the inorganic material, which are very fine inorganic material, even eggshell and all also, can be removed in grit chamber. So just remember the sequence of treatment: first is screen with large opening, then commuter, and then fine screen. Sometimes fine screen is used, and then grit chamber. Fine screen is not mandatory. Sometimes all this material can be removed in grit chamber. This depends upon how much contamination or how much you can say load is there of this material. If it's like large amount of debris are present, and then maybe like fine screen would be good to remove like fine material, and then grit chamber can be used. Okay, then oil and grease can be removed in skimming tank. So these are the preliminary treatment. So here screen is shown how the screen is placed. So this screen, depending upon the opening, it could be a coarse screen, medium screen, fine screen, etc. And the opening is given as 50 mm, 20 to 50 mm, and less than 20 mm. So this is very easy, you know, means to understand what it does. So I'm just not reading the slide. Commuter, as I said, this is like a kind of grinding machine. It grinds the big particles and make it very small, so it can be removed by in grit chamber. So basically, if required, the fine screen will be used. If it is not required, if the load is low, then it can be removed in the grit chamber. So grit chamber is grit removing device are located either before or after sewage pump. Okay, so generally the whole purpose of removing this inorganic material, wood logs, debris is to save the pumping station, right? So otherwise it will harm the pump, and the whole sewage treatment will be shut down, because we cannot pump the sewage. So therefore, sewage treatment plant to remove to prevent the clogging of the pipeline channel. So clogging will also be avoided after removing the grate, right? They separate non-decaying heavy inorganic material from the sewage, so that the inorganic material may be disposed of without causing nuisance. So see, we need to understand that the inorganic solids will not be harmful. They can be disposed of without any further treatment. However, if this inorganic solid has organic material also, which decomposes with, like, further decomposes after disposal, then we cannot dispose of them in any field, or I mean, just like there should be some kind of treatment is required. So generally the purpose of grit chamber is to remove the inorganic solid. So if the inorganic solid does not have any toxic contaminants, which is mostly the case, then it can be disposed of without further treatment. They also assist in prevention of the grit accumulation in digester and the PST. Removal of grit also reduces the frequency of cleaning of the digester. Digester is actually a unit process where the sewage is the bulkiness of the sewage is reduced. Okay, generally the sludge which is coming out from different unit processes or different operation, it will have like just 1% solid and 99% water. It's very bulky. So disposing of such sewage is a problem. Sludge is a problem. Disposing of such sludge is a problem. So digesters are used to reduce the water content. Sludge of grit chamber is disposed by burial or burning or filling the ditch and on dumping land. So these are the processes. The primary treatment. The primary treatment consists of removing large suspended. So it's a primary treatment will only include the primary clarifier or primary sedimentation tank. So after removal of grit particles, which are inorganic, mostly inorganic particle and bigger in size, only the suspended particles, colloidal particles, dissolved particles, as we have already seen the definition of this, will remain in the water, and that can be removed, like most of them can be removed in primary sedimentation tank. Okay, so this will primary treatment removes approximately 60 to 70% of the suspended solid. Then after that, if like colloidal impurities are very high in content, like, so then we know that the coagulation or other chemical process like coagulation can be used, and flocculation and colloidal impurities can be removed. Now after this, so particle removal, we know how to do, like even like if there is a more like a high amount of colloidal particles are there, then coagulation process can also be used for the sewage treatment. This is what I'm trying to say. Now after removal of this inorganic material, suspended particle, colloidal particle, if even the organic, more organic material is remaining in the sewage, which is like most common case, then secondary treatment uh, should be used. And one of the common secondary treatment is activated sludge process. It's a completely aeration process or aerobic process, in which what we do, the sewage from a primary settling tank or primary sedimentation tank is taken to the aeration tank, where the air is supplied, and the bacterial reaction or like bacteria degrade the organic matter. So rate of degradation increases as the oxygen is supplied to the aeration reactor or bioreactor, and then what will happen, the organic matter will be consumed by the bacteria and it will be changed to harmless compounds. Then the sludge will settle down in this sludge will not be settled down in this tank. This whole mixture will be taken to the secondary settling tank where the sludge will be settled down, and after like sludge is settling down and the pure not pure, you can say clear supernatant can be taken out as a effluent. So this sludge which has like organic matter, which is like decomposed organic matter and some amount of bacteria also, can be used into primary settling tank, or even it can be recycled to the aeration tank to increase the rate of biological activity in activated sludge process. So that is why it is known as activated sludge process. Active bacterial mass from secondary settling tank is used in aeration tank to increase the biological activity. So that is why the name is given as activated sludge process. Activated sludge is used. So this is schematic, the line diagram or whatever is schematic, you can also say. So here the screen after that is commuter, then grid chamber, then primary clarifier. From primary clarifier, one line is going to aeration tank, right? And from secondary clarifier, the activated sludge is coming to the aeration tank, right? The air is supplied in the aeration tank to increase the biological activity, because aerobic bacteria which consumes oxygen, they are working there. And then the finally from the secondary clarifier, the sewage can be either disposed of or can be taken for the tertiary treatment. And the sludge is either it will go to the digester for further like reduction of water in the sludge, or it can be disposed of. So one of the secondary treatment is attached growth process, which is trickling filter. So it's a kind of filter only where the sewage is percolated through the filter media, as we already discussed in water treatment unit processes. And what happens, the bacteria during percolation of water, the bacteria which are present in wastewater, they consume the organic matter and they form a kind of layer on the filter media, each like sand or gravels, whatever. And that is why it is known as attached growth process. The bacteria are attached as well with the filter material. Okay, so we are not going into detail of this method because this is not a very common method. The most common method is activated sludge process, which we will see in the next class. Final or advanced treatment. As I said, the final treatment is tertiary treatment, and that is done only if it is required. I'm just reading this 2 point. The treatment is sometimes called tertiary treatment. In most cases, secondary treatment of municipal wastewater is sufficient to meet the effluent standards. In some instance, however, additional treatment may be required. Tertiary treatment consists of removing of organic load left after secondary treatment, and particularly to kill the pathogenic bacteria. So I have explained that. The treatment which is normally carried out by chlorination is generally not carried out for disposal of sewage in water, but is carried out while using the river stream. I don't know why it is written it's not required. Okay, so the tertiary treatment I have already explained. Let me see what does it mean. Which is normally carried out by chlorination is generally not carried out for disposal of sewage in water, but is carried out while using the river stream. for collecting water. Uh, so what it's saying that the tertiary treatment is especially chlorination. Chlorination we only do, or disinfection we only do when we would like to reuse the water, the treated water. For example, for gardening, for agricultural farming, for like washing of buses or any other activity where we know that the wastewater will be in contact with direct contact with human being. So in that case only the chlorination is done. This is what it means. Okay, so is that clear? Is there any question? So I have seen the email sent by Rahul, forwarded by Rahul, and there is nothing given about the exams or quizzes, that quizzes cannot be conducted, or exams or any rule regarding the exam. The only thing is given that the attendance after, I think, 2nd of April to 30th of April should not be considered, something like that. So regarding the attendance, we have already talked about it, and we said like uh, we can consider the attendance, and whoever have 90% or more attendance, they will not attempt the extra 5 marks in major exam, and whoever have not do not have like enough attendance, means less, if they have less than 90% attendance, they can.
I don't think it's 90%, 70%.
Yeah, yes.
It was 70% in the course policy.
Okay,
Ma'am,
70%.
right.
Okay, okay. I will. Yes, yes. Yeah, you are
Ma'am,
right.
the 90% was for the best of two quizzes.
Best of quiz. Yes, yes, yes. You are right. So that I will see. Okay, 70%. Yes, you are right. Thank you for correcting.
So, ma'am, what about that best of two quizzes? Will that be applicable 90%?
Best of two quizzes will be applicable. Yes.
For all for everyone, or only for those who have more than 90%?
Who have 90% attendance or more.
Okay.
Excuse me, ma'am.
Yes.
Please upload the remaining slides.
Yes, yes, I will. I will.
And in the major exam, what portion can we expect from? Will there be any portion which was covered before the minor exam?
Oh, no, no. Only water and wastewater will come. Only whatever I have taught after minor exam will come in major. Okay.
And ma'am, what about those who missed the quiz on medical grounds? Is there any way to cover up the loss?
Okay, no. So whoever have missed the quiz one, um, I'm not going to announce anything about that, because see, I did not talk to TA yesterday. I couldn't do that. So once I will decide something, I will let you know. And yeah, but your surprise quiz will be there for sure. So if you have missed first quiz, try not to miss the second quiz. At least have one quiz done. Okay.
Yeah, but the second quiz will be counted in the second one, the first one. What about the marks I would have gotten in the first one?
Let me decide about that, because there are like many student, and I think after like in this April, or in this second quiz, or maybe in major exam, there will be more student who will complain about their absence. So let me talk to TA and we will decide about that, what to do.
Oh, all right, ma'am. All right. Thank you.
So probably
Ma'am,
one of the ways to just consider, in case you have just attempted one quiz, one of the ways to consider that only one quiz, and whatever mark you get in one quiz, that would be counted. That is the easiest way of dealing it, because the time is also not there, and the situation is also very severe. I cannot you can say, do something new at the last moment. Okay.
Ma'am, since the major will cover only portions taught after minor,
Yes.
then the weightage of the minor and major should be same, right?
What?
Equal number of classes had been taken before minor and after minor.
Yes.
So if the syllabus is almost the same, the weightage should almost be the same, right?
No. I am not keeping the weightage same. Reason is generally minor one. My experience is absent is more in minor exams, while in major exam, uh, all the students try to attempt the major exam. So I keep more weightage for the major exam than minor. This is policy I have already, you can say, announced. So I am not going to change it. What is the weightage of your major? It's a 40 marks, right?
Yeah.
Yeah, and 5 marks probably for the attendance. Like if your attendance is low, means that extra questions will come. So it will remain same. I'm not going to do the equal weightage of that. Was not decided in the beginning, and it is not going to happen.
Ma'am,
Yes.
will you consider the attendance for those students who registered the course late? I think attendance should be considered after the registration of the course.
Late registration means how much late?
Around 12th Feb around. Actually, I registered around 12th Feb. So around it was two classes were missed, and the attendance list which you posted on the teams, the two dates were mentioned in that list. So I would request you to please remove attendance absent for those who registered late.
But how will I know who has registered late? No, I do not have registration date of each of the student. So it is difficult for me to consider the registration criteria for attendance. I
I
don't.
think e-academics has a data regarding to this. I think you also probably have.
Uh, Let me see. One way is after your registration, if you have done like enough classes, nine. If I don't consider the attendance before registration, I don't know. Let me think about that. I don't want to say anything right now. Okay,
Okay,
I
ma'am.
will put it down. What can be done?
Ma'am, will assignment 2 be the same format as of assignment 1?
Yes, I think it would be probably numerical or any like. Uh, I'm like we are not giving you design problem because it is out of scope of your work, your course. So maybe numerical or whatever we have in the first assignment, that better. Probably if there is any change, it will be announced.
Okay, so please upload all the slides before giving the assignment so we can have a look.
Okay, so what I will do, I will just upload the PPTs and maybe photo of some of the pages related to numerical of self purification of river body, and if there is any changes in assignment pattern, then I will announce it. That's all. For late registration cases, I will discuss with TA and will decide something.
Ma'am, when would we be given the assignment?
First of May.
Sorry.
1st of May. May 1. May 1st.
Oh, okay.
May 1st is what day?
Saturday.
Saturday. Yeah. So May 1st or May 3rd. Saturday is okay. You can attend the assignment. It's not a big deal.
No, ma'am, and the second quiz.
Second quiz I cannot announce you. It's a surprise result. So don't worry about that. It's a 10 marks or how much? Like 10 marks. What was the surprise quiz last time? How many marks?
10 marks, ma'am.
Yeah. So 10 marks. Don't worry about that. Just focus on your major exam. Major exam is something you have to like. You will have 40, 45 marks. Okay. Fine. Thank you for attending the class. I'm just stopping the video and leaving the class, right? Okay.